Thanks everyone for joining us today. We'll start the session in 2-3 minutes. Let's wait everyone to join and settle in. Thank you. Hello and welcome everyone to another session in the DataHour series. We are thrilled to be here with you this evening for a session full of action-packed learning. I'm Vivek, part of the data science team at Analytics Vidya. For those who have joined us for the first time for the Data Hour sessions, the Data Hour is a series of webinars conducted by Analytics Vidya and led by top industry experts. It's a fun way to understand the concepts of data science, data engineering, software engineering, and blockchain from the leading players in the industry. We are hopeful that these sessions are going to be a great source of enrichment and value adding for our community members. Now, on to our session today, which is data modeling concepts. Data modeling is the process of analyzing and defining all the different data your business collects and produces, as well as the relationships between those bits of data. In this data, the speaker will demonstrate the concept of data modeling in detail. She'll also be doing a hands-on a practical problem statement for your better understanding. I hope you are excited to attend this data with this. Before we kick off, and I hand it over to our speaker, a quick recap of the housekeeping items. We are recording the session and the recording will be available on our YouTube channel. Please use the Q&A section for asking any questions you might have during the session, and we'll do our best to answer them as the data progresses or towards the end. We'll be sharing a feedback poll towards the end. You all are requested to kindly fill up that before leaving the session. Now, on to our speaker in this session of Data, we have Pallavi Naikwade with us. Pallavi is currently working as a Senior Credit Portfolio Analyst with Citibank. She has 6+ years of experience in the domain of data science while working with various companies like Accenture, BSNL, Larsen Toubro Infotech Limited, etc. She has completed her post-graduation from International Institute of Information Technology, Bangalore, in the domain of data science. And also, we are hosting this webinar live on YouTube to our official channel. The link is present in the chat window. Over to you, Pallavi. The virtual stage is all yours.
Hey, thank you, team. I won't be turning on my video. I have some issue with that. So, hello all. I think team gave a very brief introduction about me. Just just a small about update on that. I recently moved out of city, so I'll be joining a new position next week. So right now I'm not working with City anymore, just making sure of that. But yes, I have detailed experience on banking and insurance domains and mainly into business intelligence and data analytics. I worked with BSNL, L&T Infotech, Accenture, and Citibank. And my hobbies include to dance, to work out, and I'm a huge pet lover. I hope I'm audible, right? Team, can you just confirm on that?
Yes, ma'am, you're audible.
Thank you so much. I am going to share my screen. Let me know if it's visible. Is it visible? Okay. So today's topic is data modeling concepts. Not sure if everyone has attended my previous session on what is data and what all do we need to what all are the prerequisites on data analysis and how to get a hands-on on that. Now, moving ahead, I'm starting on like what to do with the data when you have a lot of data, right? What exactly do you do with that data, and how do you arrange that data so that you can systematically access that data, right? So that is where data modeling comes into the picture. Uh, we will be covering what is the data modeling, why is it important in any business scenario, right? What are the phases and the types of data models, how to build a data model, and what is normalization of data. And the last topic would be what are the common errors, what are the common mistakes usually any data analyst would do or data modeler would do while building a particular model. This is done. So let's start with data modeling. What exactly is data modeling? So let's start with what is data exactly. Data is anything that you have in real-time world, right? So anything that you are reading or you are going through on social media or on news or anything else is data for you. If you want to analyze, if you want to make decisions, if you want to make an opinion on it, right, you have to access the data. That is where it comes in picture. What is data modeling? Data modeling is a way to organize and join the data together for the purpose of data analysis. It is what we use to organize the information, okay, for multiple tables and how they are related to each other. For example, when we access an e-commerce website, right? I have multiple sources of data. I have vendors data, I have customers data, I have the website data, I have the product data. But I cannot just put it into one table and start accessing it, right? Because that's not feasible. You will have tons of data and you don't know what to refer to. So data modeling comes into picture at that time. You need to have organized tables, and you need to define how each and every table is related to each other. Now, what does it do? What does it do? The data model, what does it do? It provides a structure to the information in the system. It represents a business process, and it can also help you understand the business process. It's more like a visual presentation of either whole information or parts of it. Okay. And it based on the business scenario, it is built according to that. Rules and requirements of it are always defined by the business stakeholders. It is not defined by the data analyst. Normal developers don't do that, but they can be a part of building the data model. So it is like a high level picture of how you want to store data and how the data flow should look like. You'll probably have to work with a business person in understanding the data and how it fits together. At the same time, a business person will also learn a lot from the data model to better understand the business, how the business exactly works together by seeing that data and how it interacts with each other. it your data model shall always represent the real world problem as closely as possible, like the example that we just discussed for an e-commerce website, right? If I have customers data, vendors data, product data, shipping details, address details, location details, what is the use of unnecessary details over there, right? For example, if I have the hobbies of a particular customer, is that really going to help me out in my analysis? No, right? Is the age group going to help me? Yes. If we want to analyze on what kind of customers, what age group of a particular customer order a product basically each time. In that case, we will need the proper details, and that is where the data modeling comes into picture. The whole of the process begins by collecting information about the business requirements from the stakeholders and the end users. Um, Now, when we define a problem, whenever we define a business scenario, it's not possible that it's completely fixed from the day one, right? It can evolve based on your requirements. It can always evolve. So this process of data modeling is always a changing business need, and it helps you pinpoint the information which is required for that different purpose. For example, in a real hospital, each patient is different, right? And they should be treated individually. But when we talk about putting that data into a software, we talk about abstract patient. Similarly, when we talk about restaurants or any other field, each time you will need to make decisions about what information is important and should be included in the data model and what to omit. Here is a simple data model example. This is an employee database where we can see that there is a center table which is called the employee, and it has a unique identifier as employee identifier, which is the primary key. I hope primary key is familiar to everyone. If not, that is also fine. Primary key is a unique ID by which a particular table can be identified. For example, everyone, if there are some corporate employees over here, right? They always have an employee ID assigned to them. That is how you are uniquely identified in your organization. Okay. Similarly, we can see state codes, country codes, city codes, and a lot of them right here. Uh, how is this table related to other tables? Okay, you can see state lookup. Also has a state code which uniquely identifies a particular state. That is the primary key for that table, and it has a description for that state. Similarly, city table has a primary key as city code, and it has its description. Now you have country table again. Um, Sorry, I think this is a mistake. It should be country code and not city code. And country table, country description as over here. It's something that is wrong. Then we have employee lookup, where we have employee identifier and his description. So this is how you organize the data, and this is a particular data model. What if you include unnecessary details over there? Is that going to help in your data analysis? No, right? So you need to predefine your requirements and start modeling your data according to that. This is how a database will be created for a particular employee. Moving ahead. Now, why is it exactly important? Okay. Like I said, for employee database, right? If you start having unnecessary details or or redundant data in that case. Is that going to help you? No. In fact, it will just add up on your work to remove the unnecessary data and find out the perfect data for your analysis. Why is it important? It's just because when you extract the right information, right, you have the higher quality of data. Just as architects consider blueprints, those are built while constructing a building, right? You should you should consider blueprint. In the similar way, before building a database, you should always consider the data that you have and then build a report on it. Development efforts can fail majorly due to low quality of data and premature coding. If you define the problem, it enables you to consider different approaches and you can choose the best one amongst it. Sorry, just a second. A clearer scope. What does that mean? Means you have your requirement completely understood, right? You have a complete understanding of what you want to do with the particular. Sorry, just a clearer scope means you are completely familiar with what is the requirement for a particular business scenario. A data model, it will provide a focus for determining scope, provided something is very tangible to help the business stakeholders and developers. They agree over. I'm so sorry, team. Just give me a minute.
Uh, for everyone, please use Q&A sections for your questions.
Um, so provided something is flexible, right? Your business scenario, if it's flexible, even the business stakeholders and your developer should agree on that, and they should decide on what is to be included and what can be omitted. Business users can also see what the developers are building and compare it with their understanding, so that they both work hand in hand and reach their goal with a clearer idea. Third is reduced cost. So you can build applications at lower cost via data models. Data models typically consume less than, like, what you can say, 7 to 10% of a project budget, but it can reduce 65 to 75% of a budget that is devoted to programming. How did I come up with the number? So if you have a proper data model, right, you can catch the errors and oversights early when they are easy to fix. This is better than fixing errors once the software has been written, or that's even worse yet, right? So that is how you can reduce the cost on development efforts and everything. Also, faster performance. A good data model simplifies the database tuning. Um, it typically runs fast, often quicker than expected. To achieve that for a performance, right, the concepts on your data model must be very crisp and it should be coherent. Okay. So, any doubts still here? We will clear it in the end of the session. Better documentation. If you have a proper data model, right, you can define each and every table, what they are doing, what is the purpose of having that table, and how is it related to another table. So that is how it will be helpful for documentation purpose. In case a non-business person wants to or a layman wants to understand what exactly your data model is doing, right? So that will be helpful in future as well. Moving ahead, phases of a data model. Now, how should your exactly data model look like? It's usually created in a graphical form. Okay, you have to create a diagram which identifies the main concepts of the domain, the features, and the relationships. Okay, So when we start building a data model, there are three layers to it, three phases to it. There is first conceptual data model, right? Over here, you can see that it is a product related information. Conceptual means it helps you visualize the concepts and rules that govern the business process that you're modeling without going into the technical details. It's like an overview of how the data is going to flow. um, we were discussing an e-commerce example, right? So we discussed about the customer information, the vendor information, the shipping details, the product information. But do we need to go into the detail levels of it, like what columns are there? No, it's just an overview of what how the data flow is going to be, how each and every table is going to be related to each other. You use these visualization to align to the business stakeholders, system architects, and developers on the project. What information is there in the data system will it will contain, how elements should be related to each other and their dependencies. So it's basically a concept. It's a high level view of the system, uh, uh, of the content organization and the relevant business rules. A business rule could be that each vendor has to supply at least one product. So all such rules, right? They can only be decided um, when we are building the conceptual data model. These cannot be defined when we are actually developing something. So there is no standard format for conceptual data models. What matters is everyone should align and agree on the purpose, scope, and design of that data project. Moving on to logical data model. Um, Logical data model is based on the conceptual data model and defines the project's data elements and its relationships. You see the names and data attributes of specific entities in the database. For e-commerce example, the products are identified through a product ID and properties like description, category, and unit price. Data architects and business analysts use the logical data model to plan the implementation of a database. So now that we have now that we decided the data flow and how should what are the business rules related to each and every table. In logical data model, we define the names and the attributes for that. So vendor table can have the vendor ID, the types of products they are sending, the types of products they're selling. It's like more of a high level view of the description and the attributes. And finally, the physical data model. A physical data model gets more technical. Database analysts and developers use it for the design of a database and relevant data structures. The physical data model specifies the type of data you will store along with the technical data requirements. For example, it will have the data type specification, whether a piece of data is an integer or a decimal number, or it is a text, or is it alphanumeric. So it will have all levels of granularity, all levels of detail in the physical data model. And data model is mainly used by the developers itself, only to build that database. So data modeling, it doesn't require any tools. It can be done on a dry erase board or with a pencil and paper, or it can be done on an Excel sheet as well. So you just need to make a blueprint on an Excel sheet, like how is your each table having what kind of data and what kind of attributes and what kind of data type, what is the use of a particular field in a particular table. So that is the level of detail you can go into physical data model. Most commonly, if you see database analysts or developers, they most commonly use relational data modeling. Although an older approach, it's still relevant, which shows the data in fixed format records and arranges data in tables. Um, how is it storing the data? They have measures which are numeric values such as quantities, and you can have mathematical calculations done on that, like sum or average. And then there are dimensions, which can be text or numeric. They're not using any calculation, they just are the description of a particular attribute.
Excuse me, ma'am. Ma'am, you are inaudible.
Hello, am I audible now?
Yes, ma'am, you're audible now.
Okay, thank you. I'm so sorry. I think I had some issue with my headphones. I'll just resume back to the schema. So right now over here, you can see a star shaped structure, right, in which there is a fact table and then there is a dimension table. Um, so how does this star schema help? It is a data model which is widely used to develop or build a data warehouse, mostly data marts. It includes one or more fact tables, mostly one fact table, and these fact tables have an indexing any number of dimension tables. The name is derived from how the diagrammatic representation of it looks like, with dimension distributed around a fact table. Now, what are fact tables and dimension table? Now that um, you have seen the structure, right? The fact tables, these usually consist of facts like metrics recorded in a business as business transactions happen. Um, for a fact table, it will only have the unique keys of a particular table. Like here you can see there is order ID, customer ID, product ID, purchase date. So it will have only the unique details of a particular dimension. It won't have any description of uh, any particular table or anything. So this is like a center of all the information. If you want any level of detail, you can just derive it from this fact table. Uh, Moving ahead to dimension tables. Dimension tables, it consists of descriptive attributes that define the facts which are being measured in the fact table. Like if you can see customer ID, right? This is related to this dim customer, which is a dimension table. Now, the dimension customer table will have the customer ID, its address, its maybe if we can add to this, it will have the age of a customer, it will have the email ID of a customer, it will have the phone number of a customer. So that is how a dimension table works. It will have the descriptive details of a particular requirement or a particular table. Okay. um then there is dimension date table, where there are different dates, quarters, years, dates, like that.
Now, what does it take to build a data model? So you need to first determine the business requirement. You need to determine what kind of data you want to start working on, and then define the relationship in between that data. You need to you need to distinguish your data in between facts, measures, and dimensions. Now, when it comes to facts, dimensions, like we discussed in the previous example, right? You need to have only the key details in the fact tables, not descriptive details. Usually, fact tables will only have uh, numeric uh, numeric data. It won't have text data. So dimensions will have more of text data. It will be more descriptive on a particular uh, detail. So you need to define all of that. So you also need to create a high level conceptual data model and then get it approved from the business entities. You need to create a new logical data model, add to the following a logical data model, whatever uh, extra requirements that come up, right? You need to add that to the logical data model. You need to select the target database where the data model tool creates those scripts for physical schema. Usually we don't go for that approach. We usually take up Excel or mainly pen and paper just to build up our data model. We don't usually go for Urban Data Model Builder, but if you can give it a try if you want to. Um, After that, once you have built the logical data model, right, you need to you need to create the naming conventions for logical and physical objects. You need to create the entities. You need to create the attributes. When I say the creating the entities, creating the attributes means you need to create those tables in your database. You need to create a particular table. You need to create particular columns in that table. You need to define which is the primary key of that table. You need to define what are the surrogate keys, what are the foreign keys, or you need to define any constraints. Like, for example, if we say uh, the name of customer, right? It cannot be blank. So you need to mention all those constraints while creating that table, right? So that is how you create those entities, and then you need to assign a particular data type to that attribute. You need to analyze the relationship between entities and create foreign keys relationship between the entities. Now, what is foreign key? In the previous example, we saw that a customer ID was a fact was there in the fact table, but which was also a primary key in the customer table. So in the in the fact table, it is working as a foreign key. That is what a foreign key means. After all of this done, after you have created all the columns, all the tables with all the required columns, you have defined the relationship in between them. You need to get validate the data model and then start building the reports from that data model. So choose the business process that you want to use to analyze the subject area to be modeled, then determine the granularity of that fact tables. Then you identify the dimensions and hierarchies for each fact table, then identify the measures of the fact tables. So this is how step by step you can work on the data model. Now, before entering the data into the data model, right, normalization is very necessary of data. What is normalization? It's like an essential part of product information management, and it prevents the data from being replicated in two tables at the same time, or unrelated product data being gathered together in the same table. It helps to streamline your data, okay, and make it more compact, make it more precise in terms of storing the data. It's simply the process of removing any duplicates or anomalies within your collated product information. This is done by analyzing the information within your product tables and then finding the links between the related information. This is why it is very necessary to normalize your data before moving it into any tables. Now, what are the types of normalization? There are types of normalization. When we go to first normal form, It removes the duplicates and it creates separate tables for groups related data. If you see over here, we have an example of a particular table in which there is a course ID one. The course name is physics, but there are two instructors over here. So you need to separate out. You cannot have duplicate data in this, or you cannot have groups of data. So you need to separate them into two columns. So there are two ways of doing that. Either there can be one physics, Dr. Suresh, and then we create a new column with instructor 2, Dr. Mahesh, or we can have another row with name saying course ID 1 physics, and instead of Dr. Suresh, we can have Dr. Mahesh. But in that case, we will have the column name as only instructor and not instructor 1. Okay, so there can be two ways in which this can be done as well. So this is the first normal form where you simplify the data and put the extra data, put the grouping of the data into a separate table. This is the first normal form. The second normal form, it removes the subgroups. Now, first, in the normal form, we removed the grouping. Now, there can be subgroups as well, right? So, in second normal form, we remove the subgroups of the data present in multiple rows of a table, and it creates new tables with connection between them. So, for example, over here, you can see this employee ID 1 with John, and then his job title is web developer. Again, there are 5 different people with some of them having the same job title. There is one more way we can make this precise, right? We can assign a new table to job description itself. We can have a unique ID for a particular job ID, and then assign a job ID over here. Like if you can see, there is 1 for web developer, 2 for application developer. So this is how you can just create a link in between them by creating a particular job ID, giving it a unique identifier. So if there are duplicate values, right, they should be stored in their own separate tables. And then this one, sorry. This one is a primary key in the job titles table, but it is working as a foreign key in this table. Over here, the values of foreign keys can repeat, but over here, the values of primary key cannot repeat. So that is how it second normal form works on it. You create new tables with precise details. Last, we have third normal form. Third normal form, every non-key column means apart from the primary key, right? Everything must be independent of each other. So if there are any interdependent columns, right, you break those relationships, you break that and create a new table out of it. So if you see over here, city and state, a particular city will have only a particular state. It is not possible that, for example, Bangalore is there in Karnataka as well as in Maharashtra. No, right? Bangalore is there only in Karnataka. So if we define it that is it is that unique, then we can have a new table in that case. So over here they created a new cities table and a states table. So a particular city will only be found in a particular state, and that is how you remove this transitive dependency or the functional dependency of each other and make it more easier to read. This is the third normal form to store any data. It can also delete the columns that not depend on the main key value, right? So there are phases in normalization, database normalization also. You need to create different tables for each value, or locate duplicate fields in a table and then place them into different tables and link a key to each other. Then you can create connections between values in different tables, between a table of colors or table of sizes of clothing product. Add connections between the main columns and the non-key columns. This is how normalization phases work on. There is also denormalization that we can do. It's a database optimization technique in which we add the redundant data to one or more tables. Like over here, this is the denormalized data. Everything is there into one table. If we see the e-commerce example that we were discussing in the past, right? We can have all the customer details, the order details, the vendor details into one table. But is that really feasible? Is that really readable? No, right? That is why normalization is very necessary. So uh, these are the steps to make sure that your data is ready to enter a database, and then only then you can move ahead with the data model and putting data into inserting data into your data base and tables. So there are a lot of things that we discussed, and you have a particular goal and you want to gain a particular actionable item. You want an actionable insight from the data that you have been collecting. So how to make sure that your your data model can actually gain these insights and answer the business questions that you have, right? You plan for those things. When you plan, when the planning stage is skipped on, the result is very horrible. The performance and the analysis suffers. The data integrity, there is a question of integrity, database security issues ensue, and overhead for maintenance and development balloon. So we are going to take a look on the common mistakes that are made when modeling your data in preparation for analysis. If you miss out on these mistakes, it will only cost you on huge time and development efforts. First is starting without a clear plan for action. When it comes to modeling data sources for analytics, there's a data warehouse. It is very vital to plan out what its goal will be. There are several reasons for this, like you cannot have efficient use of your analytics resource. Your developers will be constantly redoing the same things again and again because they don't know what your data model consists of, right? So the best practice is to plan, design, and allocate resources for each area. Like for example, the customer table that we, sorry, the e-commerce example. You can have a particular team making sure that a customer's table is doing fine. We have the right data. They can validate the right data in customers table. Another team of one or two people can make sure that the vendor's table is doing fine. We don't have redundant data over there. It is possible to include too much data into one resource with but with data modeling and disparate data sets, you would still want to be careful to avoid data storage issues, data duplications, and unnecessary overhead. This step in planning will allow you to identify your overall goal of your analytics model. Second is inadequate use of surrogate keys. When you're bringing a lot of data together, right, from multiple sources, and then a popular strategy for ensuring that the data has unique identifiers is providing surrogate keys. However, it is not very necessary or a very good practice. Often it's a natural keys, like for example, an natural incrementer, right? It's an incrementer. If there are some developers over here, they would know that it will automatically increase its value whenever there is a new record coming up. So that is a natural key which will automatically work as a primary key. So that is one thing. So you cannot rely on the surrogate keys if your data model is not correct. Poor naming standards. Poor naming standards can really throw an obstacle into data related activity. This is like a very vital step in planning the data model. Skipping this step can really bring down many frustrations, especially when the data is brought together from multiple resources. For example, if you name a customer's name as customer description, or you just rename it very wrongly. Will that make sense to the developer when he's building the database? No, right? So this is very important when you build a data model and give it a particular give it the right name which describes that field correctly. Wrong levels of granularity. Granularity refers to the level of the detail that our data allows us to see. For instance, take a time and sales dimension as example. During an e-commerce business, granularity would be how small of a time frame can we look at per hour. If we had the data to see how many transactions took place, how many orders were placed per second transaction, uh, that would be granularity. This is an issue that needs a nice balance. Too much like if you have like extra a lot of tons of extra data, then that could be very difficult to navigate for end user, which might be a business executive that is more interested in the big picture. If you have the right data, right, you won't be adding extra levels of granularity, or you won't be skipping any levels of granularity. Now, there are a lot of calculated fields. When we say for an e-commerce field, right, there is a product that a particular customer is buying for, suppose, $100. Vendor is selling it for 70 or $75. In between, if we want to calculate the profit of that e-commerce platform, right, this is something that we need to calculate, right? It's not available in any of the tables. It's supposed to be it's supposed to be a calculated fee. While you build a data model, right, you need to pay attention to what kind of fields need a external calculation, and you don't want to miss out on that. That is why this is very important. Dimensional hierarchies, let's not go there for dimensional hierarchies, because that itself is a very different topic. Let's go to the last one: ignoring small data sources. When you have tons of data, you don't want to be missing out on level of details also, right? If you have 90% of data and 10% is missing, would that really make sense on your analysis? No, right? So you need to gather each and every piece of data from each and every smaller data sources. There is a very common mistake of ignoring these small data sources, and then it results into incomplete data model, incomplete report, and incomplete analysis. That is why make sure that you are covering each and every data source in that case. I'm done here. So any question and answers, you're welcome for that.
Before we proceed to answer questions, I would like to request attendees to please fill in the poll about feedback, as it helps us to conduct more such sessions. Yes, ma'am. You can continue for the question and answering sessions.
Okay. The first question is by Francisco. How is data modeling different from data engineering? So, Francisco, data modelers, they are the data architects, right? They analyze the business requirements and then they design the database tables, columns, and relationships, and the documents, data flows, and dependencies. They also create the description of data, like data dictionaries, and mapping of it is done by data modelers. But what data engineers do is they um, design and build more complex systems that collect and store data for organizations. They work closely with the data scientists to understand what kind of data is needed. Um, and their job role mainly involves designing the pipelines, how the data will flow, and how efficiently can we handle the data flow when it's like millions of records, millions of transactions that are happening each and every day. So their job role mainly concerns of optimizing the databases and making sure that each and every transaction gets loaded into the database. So they mainly work in Hadoop, Spark, and NoSQL databases. I hope that answers you. Francisco has one more question. Why might one consider denormalization when normalization appears to be always right approach when doing data modeling? So denormalization, if you want to have each and every piece of data into one table, you don't want to perform unnecessary joins, right? If you have a smaller database, if you have a smaller amount of data, right? So in that case, denormalization is uh, done. So it can help us avoid costly joins in relational databases. Basically, it's a process of making it non-normalized and then avoiding all those unnecessary joins in a particular query and then just having it into one view. For example, a few years ago, I was working on a project where we were bringing down the data from multiple countries into one single table, right? That is also a project of denormalization. We were taking data from different sources and taking it into one particular table where it was one view for all the countries that we were working from. So there can be chances where you also need to have denormalization in your business case. Later on, what are the requirements to determine foreign key and primary key in a table? So later on, primary key will define a particular table uniquely. A foreign key is not supposed to define a table uniquely. It's a primary key of another table that we are pulling in. So if you have employees table and if you have the managers table, right? So employee table will uh, uniquely define each and every employee. But if you want to have a manager ID as well, right? So in the managers table, you will have a manager ID, which will be a primary key for that table. But if you want to pull it into a particular employee details, like who is the manager of that particular employee, then the manager ID will work as a foreign key in our employee table. That's how you can determine those foreign key and primary key. Foreign key doesn't have to be unique in that table, but it has to be a unique key in where it has been defined as a primary key in another table. Satyendra is asking, SQL table normalization comes under which phase? It comes under the logical data model phase itself, Satyendra. So we find that over there, and only then we can start building the attributes and then the physical data model. Francisco, are there any substantial differences when designing a database versus designing a data warehouse when it comes to data modeling? Data warehouse can be a single table as well, Francisco. It can be a single table or it can be a multiple tables as well. But a database will always have multiple tables. A data warehouse can be a single overview or a monthly snapshot or a monthly view of a particular business requirement, right? So database will have all the history transactions, it will have day-to-day transactions, but data warehouse will have only the history snapshot. It won't have the current live data as well. David is asking denormalization. Denormalization, I think I answered already. Database refactoring, logical schema. David, we went through logical schema, I think so. So then there's ontological engineering utility in data modeling. David, I'm sorry, but I've not been through that field of data modeling, so I'm not sure how to answer on that. George is asking what criteria decides the granularity, the user, the problem, the business. Usually the business decides the level of granularity, George. So they'll decide what kind of what level of details they want. And if while building that data model, if the database analyst or the developer feel that even this should be necessary, then that can be discussed with the business stakeholders and can be brought into the picture. So granularity as such, 90% is decided by the business stakeholders, but then only then 10% of it can be moved ahead into logical data model or physical data model. How to improve data modeling skills? Just start building data models on paper, take case studies of e-commerce, maybe Netflix, maybe restaurant chains, or take various real life examples and then start building data models on paper first, like what kind of information you can have, then move to Excel slowly, and then you can maybe you can maybe reach out to an industry expert to validate your data model or maybe ask for suggestions in there. So just give me a second. Mayank is asking, in NoSQL databases, is normalization done? Mayank, I'm not sure of that, but I think it can be done in NoSQL databases, but there are no rules to follow, like how we follow a lot of rules in normalization, like the first normal form, second normal form. I don't think there are so many rules application, because in NoSQL they're not related to each other, right? So that those rules won't make any sense, and it won't be able to store data in the relational manner to begin with. So I don't think so. Ma'am, can you give an example where going through data model escapes an error must have occurred otherwise? Um, Example where errors. I think we went through a lot of examples, right? So um, maybe you can just refer to that one. Like for example, data errors. You can avoid data errors while going through a data model. If in logical data model you have described a particular field needs to be of this data type, and then in report you are seeing a different data type of that field, then you can always refer to your data model, like what was the original data type that was supposed to be. So in that case, data models or the blueprints always work on. It's like the um, one shot thing that you can always refer to in case of any confusions or any mistakes. Namit, hi, can you explain a project end to end in brief where data modeling played a key role? Data modeling plays a key role in each and every project, Namit. Be it any industry, be it e-commerce or insurance or anything. So um, you can just go through any example, because explaining the project end to end would take a lot of time. But we went through a lot of examples in e-commerce, so you can just try working on that. And if you have any doubts, maybe you can reach out to me. Monali, your question is, what is the difference between PK, that is primary key, and foreign key in fundamental analytics? I answered that already. Primary key defines it is a unique identifier for a particular table. Foreign key is a unique identifier of another table that we are referring into one another second table. So it need not be unique in this table, but it has to be um, unique in the table that where it is defined. Gulzar, skills required to be data analyst. Gulzar, you can refer to my previous session. Maybe the team can forward you the YouTube link of that. So that was completely on data analysis. Anju, generally is data modeling done by data engineer or data analyst? It's mostly done by data analyst, Anju. There are roles like data architect as well, or business analyst, who completely work on this thing itself, where they are completely focused on getting the business requirements and building a data model. So data engineer will more focus on the physical part of it, the physical data model or optimization of a particular database. Ramanika, can you share your experience of data normalization? Where normalizing, did you do it during data modeling production or after the data has been deployed? No, we always normalize the data while the data model is created, right? During that production, we don't normalize it after the data has been deployed already. Francisco, any suggested approach when mistakes were made during data modeling? The DB is now live, but it makes sense to change the schema. to fix errors on data only. That can always be the case, Francisco. I mean, nothing can be 100% perfect, but if there is a chance of fixing any data model, even when it goes live, right, there is a chance by fixing it on the schema as well. Um, I haven't had a chance of working on that, but I think it can always be fixed, even when it is live. I think that's all for today. I'm done from my side. Thank you, everyone. You've been a great audience.
Thanks a lot, Pallavi. On behalf of Analytics Vidya, I would like to thank you for your time and delivering such a wonderful session. I'm sure our audience found it insightful, and hopefully, we can conduct more such sessions with you in the future. The LinkedIn profile is provided in the chat section. I hope you guys have filled the feedback poll. If not, I request you to please fill in the poll about feedback as it helps us to conduct more such sessions. If you wish to conduct a webinar or are facing difficulty in registering, connect with us at the mail which is provided in the chat section. The recording will be live on the YouTube after 2 days. We'll be back with another session on the data. The link is in the chat section. Till then, bye bye and keep learning.